Interthread communication in Java. Interthread communication in Java facilitates coordinated execution and the resource sharing among the multiple threads within a single process. Here, this is a process here. In this process, assume here we are having threads like this one. Thread 1, thread 2, thread 3, thread 4, and so on. In threads order 1, 2, 3, 4, and so on. In threads order. Assume these threads wants to use the same resource here. There is a resource here. These threads want to use the same resource at a time. At the time, we have to put the communication between these threads here. That concept is called as inter-thread communication. While during the execution also, they are putting a coordination here. For the coordination also, we need the inter-thread communication here. This mechanism is crucial for preventing the issues like the race conditions and deadlocks in the multi-thread application here. Means to avoid the race condition and to avoid the deadlocks here. Means there is no chance of getting deadlocks here. At the time, we have to put the communication between these threads here. The inter-thread communication primarily achieves the inter-thread communication through the wait, notify, and notify all methods. To implement this concept here, we have to require the mainly three methods. The first method is the wait method, second one is the notify method, and third one is the notify all methods. Come to the first one, wait method. The wait method causes the current thread to pause its execution and release the lock until on the object it is synchronized on it. Here assume here this is the thread 1. It is putting a lock over the some object here. Whenever there is a wait method, there is a wait method here, this thread will goes into the wait state. It releases the lock on this object, and whatever the lock it is putting the object here, that will be released here. The thread enters into the waiting state and remains until the another thread notify or notify all on the same object. Whenever the thread 1 is entering the waiting state here, to invoke this thread here at the time, it can be invoked by using the notify or notify all methods here. Here the wait method, it must be called within the synchronized block array method here. If you want to apply the any wait method, that must be present within the synchronized method or a synchronized block only. Come to the notify method here. The notify method do is it wakes up the single thread that is currently waiting on the object's monitor here. To invoke the object here, to invoke the thread, at that time we are using a method that is called as a notify method. If multiple threads are waiting, only one appropriate thread has been chosen to be awakened here. Whenever more than one thread is waiting here, but by using notify method we can invoke only the single thread only. It must be called within the synchronized block array method. The wait is also same procedure. It must be called within the synchronized block array method only. Come to the notify all. Wakes up all the threads that are currently waiting on the object's monitor. Here the by using the notify we invoke only the single thread only. But by using the notify all method here, we can invoke the all the threads which are available on this object here. All awakened threads will then complete for the lock on the object. It must be called within a synchronized block array method here. This is about the notify all method. The best example for the internet communication is the producer consumer problem. This is a very important problem. Uh, Consider a shared resource like a queue accessed by the producer thread and consumer thread. Here we are having a resource here. This is a queue. This queue is accessed by the two threads. The first one is the producer thread and the second one is the consumer thread. The producer thread do is it is adding the item into the queue. The consumer thread do is it is removing the elements from the queue here. To adding up the elements duty is the producer thread duty. The consumer thread duty is it is removing the elements here. Come to the producer thread. If the queue is full, the producer thread calls wait on the queue object, releasing the lock and entering into the wait state until the space becomes available. Its meaning is like this one. Whenever the queue is full here, assume here the queue contains like 1, 2, 3, 4 and 5. this queue has been full. If the producer thread wants to add the one more element here, it is not possible. Why? Because the space is not available. Now, in this point of view, the producer thread will enter the waiting state here. Why? Because the queue has been released here. Whenever the queue will not release the data here, at the time, it is not possible to add the data. After adding an item, the producer calls the notify or notify all to potentially wake up the any waiting consumer threads here. After adding the any item into the queue here, the producer thread always invokes the notify or the notify all methods. Why? Because whenever the notify is taken by the consumer method, at the time it can understand that yes, the data has been available in the queue here. They can delete the corresponding element here. Come to the consumer thread here. If a queue is empty, the consumer thread calls into the waiting state on the queue object here. Assume here this queue is empty one, there are no elements are there. In this point of view, the consumer will enter into the wait state here. Why? Because there are no elements are there. Whenever the producer will add the element into the queue, at that time only it can take the data and it do the corresponding operation here. After consuming an item, the consumer calls the notify or notify all to potentially wake up any waiting producer thread here. The consumer thread will enter the waiting state here. Whenever the producer is adding the data here, it is sending the notify method or notify all method here the to invoke the any waiting threads here. These are about the producer thread and consumer thread. Producer thread duty is the adding element into the queue. Consumer thread duty is the deleting the elements from the queue here. Means removing the elements, consuming the elements from the queue here. Whenever the queue is the empty one, then the consumer thread will enter the waiting state. Why? Because there are no elements are there for the consumer purpose. Whenever the queue is full, the producer thread will enter the waiting state. Why? Because there is no space to add the element here. This is about the producer and consumer problem. Come to the code point of view. Here I am writing the code like this one. Class shared resource. The class name is the shared resource. It contains the two variables. The first one is the data part, private integer data. The second one is the available part here. Means whether the data is available or not. Private boolean available. Here I am taking the default value is the false here. Shared resource class contains the two variables, data and the available. Data our good is it is taking the data from the user. Available is whether the data is available or not. At the starting stage there is no data. I took the value as false here. Synchronized void produce. Okay. Here the what is the producer data here? The producer data is adding the elements into the queue here. Come this one. Void produce integer value. While available. If the data is available, then try waiting state. We will enter the waiting state here. If there is no exception here, or that this will if there is an exception here, then we can enter this block here, interrupted exception. Here the data equals to value. Whatever the value we are setting here, that will be stored in the data place. System.out.println produce data. What is the data has been produced here? Then after that available equals to true. Why? Because the element has been added. Yes, now we are having the queue which contains the data here. The available data is true here. Notify. Whenever there is a notify here, it is invoking the consumer thread. Why? Because the data is available. Now you can invoke and remove the corresponding data here. Synchronized void consume. Here this is a synchronized void produce here and this synchronized void consume here. The consume duty is it is deleted elements from the queue here while not available. If the data is not available, then try into the waiting state here. Whenever the queue is not empty over here, in this point of view, the consume will enter a waiting state here. System.out.println consume data plus data. If the data is available, then it will consume the data. Available equals to false. Notify. It is invoking again producer thread here. Here in the produce point of view, notify invoke the consume method. In the consume point of view, notify invokes the produce method here. Here there is a synchronized keyword here. Now these are called as the synchronized methods or the synchronized blocks are there. The notify method and wait method, they are all in the synchronized blocks only. Come to the main class. Shared resource equals to new shared resource. We are creating the object here string args shared resource. For this shared resource class, we are creating the object. The object name is the resource. Thread producer, new thread. We are creating a thread. The thread name is the producer. Thread consumer equals to new thread. We are creating another thread. The thread name is consumer. Here, in this one, I am passing correlation for integer I equals to 1, I less than 5, I plus plus. In the producer thread, we are having this method here, produce of I. It has been invoked how many times here? 5 times. After invoking the each and every time, the value will be sent to the data place. After that, produce the corresponding data. Available equals true. Why? Because in the queue we are adding the element. Now it is available. Notify. Whenever there is a notify, the control will jump to the consume method. Producer dot start, consumer dot start. The producer thread will be called and it will go into the waiting state. After that, consumer thread is invoked and it is doing the operation. Again, it will go back to the previous position here. At a time, only one thread can be executed here. See the output here. Producer 1, consumed 1. Producer 2, consumed 2. Producer 3, consumed 3. Producer 4, consumed 4. Producer 5, consumed 5. Means once the data has been provided by the producer, that data is immediately taken by the consumed here. This is about the producer